Hello guys, welcome back to the video. So today in this video we are going to discuss about measures of dispersion. In my previous two videos I have discussed about measures of central tendency and basics of statistics. If you haven't watched them, I highly recommend you to follow the playlist which is in my description box to go through them and then come here. So now after completing measures of central tendency, we are here for measures of dispersion. So in this measures of dispersion, first we are going to discuss about variance. So let us see what is the definition of variance. So first of all, I will explain you the definition of variance, and furtherly I will implement that problem to you and explain you in more detailed way. So basically it is the summation of squares of the difference between each data point to the mean divided by total data points. This is called as variance. And now let us understand why we will use this variance. We will use this variance to understand the spread of the data. So first of all, what is this spread of the data? For example, let us take a graph and let us think that this is x-axis and this is our y-axis, and I want to plot some points. Maybe let us think that these were the points. This first one, second one, third one, fourth one, fifth one, sixth one, seventh one, and then eighth one. So if I want to join these points, maybe I can draw it like this. So after joining all the points, we may get a curve, something like this, which is in blue color. So now the area between these curve is called as spread. So the variance will be used to understand about this spread, and there is a correlation between variance and spread. That is, if variance increases, then obviously this area will be going to be increased. For example, let us say that this area is somewhat 10 points. So if variance increases, this will also be increases. That means it may have point like 10. But if let us think that if variance decreases, then we may assume that this spread also will be decreased. That means it may be any number which is less than the previous number. For example, let us say maybe it can be 4 or 7 or 5 or anything else which is less than 10, and also the spread will became very small. Maybe it can be like this. So previously this is all is the spread, but now this could only be the spread. That is the correlation between variance and spread. If variance increases, the spread will be increased, and if variance decreases, the spread will be decreased. So now let me explain you about how we can calculate variance. But before that, you have to understand that there were two metrics to calculate variance. The first one is for population. So we have to calculate population variance, and also maybe you can have something like sample variance. So before that, let me tell you what is this population and what is this sample. For example, let us consider there is a school which has 100 students in it. So the total number of students in it is 100. So we can call it as population. But if I want to take some people out of these 100 people, let us say if I want to take only 20 people out of these 100, then this will be called as sample. So we can define sample as the portion of population. Population means we will have entire data, but sample means we will have only some particular kind of data. This is the sample and population. And for variance also, we will have different formulas for population and sample. And let me explain you those things now. So this can be population, and we'll take here as sample. So in population, variance is defined by a formula called as sigma square, whereas in sample we can describe it like s square. And for this one, as like the example, we can write the formula. So what is the definition of this variance? It is nothing but the summation of squares of difference between each data point to the mean of the data set divided by total number of numbers. So here, based on the definition, this could be the formula for the sigma square, which is variance of the population. And here also we have to take the summation from I is equal to 0 to capital N, which is the population. That means total number of items in the population. That means, for example, from this example, we can consider this as N, which is the total number of data available in that. And Xi is the each particular data out of those 100. And mu is nothing but mean of the population. So this is the formula to calculate variance of population. But whereas coming to the sample, we may encounter different type of formula. So here also, first of all, we will use S square as variance of sample rather than sigma square, which is in population. So here also, we will have summation of from 1 to n, because here we will represent it in capital N in population, but whereas coming to the sample, we will describe this total data set's number as small n. So that's why here from I is equal to 1 to capital N. And also Xi is nothing but each data point, and instead of mu we will use X bar here. So why we are using X bar means, for population mean we will use a formula called mu, as we already know it. But for sample, while we are calculating mean, we will use, or we will denote it by the formula called X bar. So that's why we are going to use X bar here. See, both mu and X bar will do the same work, but while representing population and sample, we will denote them with different characters. That's all, such that no other difference is there between these two. But here we may have one difference, is that in population, while calculating the variance, we will use total number of data sets, but here we will only use n minus 1 number of data number, because while doing sample, we will lose some degree of freedom. In order to cancel those all fluctuations, it is better to use n minus 1 instead of n. And it is not only better, it is compulsory we should use n minus 1. There is also a theory called Basel's theory, you may have seen it in your mathematics before. So based on that Basil's theory, this sample, while measuring the variance, if we use directly in, we may lose some degree of freedom. So that's why we have to use 1 point lesser so that it all will be fixed and we will get the correct output. So I'll write the formula more clearly here. For sample variance, we will use S square, and it is from sigma I is equal to 1 to n xi, which is the particular data points, minus x bar, which is the mean of the sample, and will whole square it divided by n minus 1. I may also write the population variance formula here. So it is sigma square is equal to, from I is equal to 1 to capital N xi minus mu, which is nothing but the mean of the population, divided by n. So these are the different formulas for population variance and sample variance. Now what we can do is we can take a simple data points and we can try to find the population variance and sample variance of for that example. So let us do it now. Okay, now for example, consider that we may have some data points like x is equal to 1, 2, 3, 4, 5. Let us take this as our data point. So let us consider the variance for both population and sample for this example of x. So let us now write the formula for population variance, which is sigma square is equal to summation of I is equal to 1 to n xi minus mu whole square by capital N. So first is first, let us write all the points here. So first one, what we have to find is xi, and then we have to find mu, and then we have to find xi minus mu whole square. So these are the major points which we have to find in this example. So let me write the xi here. So as we taken data set from 1, 2, 3, 4, 5, I will write 1, 2, 3, 4 and then 5 here. So now let us find this mu, which is the average. So mu is equal to 1 plus 2 plus 3 plus 4 plus 5 divided by 5, because we have 5 numbers here. So that will equal to 15 by 5, which equals to 3. So mu value will be 3 here. So now xi minus mu whole square, that means 1 minus 3 whole square, and then 2 minus 3 whole square, 3 minus 3 whole square, 4 minus 3 whole square, and 5 minus 3 whole square. So the values of it would be equal to, so 1 minus 3 whole square is minus 2 whole square, which is going to be 4. 2 minus 3 whole square, minus 1 whole square going to be 1. 3 minus 3 whole square going to be 0. 4 minus 3 whole square going to be 1. And 5 minus 3 whole square going to be 4. So these are all the values of xi minus mu whole square. But in the formula, we have to do the summation from point 1 to point n. That means we have to add all these values. So 4 plus 1 is 5, and Here also 4 plus 1 is 5. So totally 5 plus 5 is equal to 10. So after doing the summation, we got the answer as 10. So now sigma is going to be 10 by capital N. That means 10 by, what is the value of capital N? It is nothing but 5 because we have 5 different data points. So now it is going to be 2. So here we have to take sigma square. So now sigma square is going to be 2, which means the variance of the population is 2. That is the answer which we got. But now let us do the same for this sample, and also let's see what will be the answer. First, let us write the formula for sample, which is S square is equal to, from sigma I is equal to 1 to small n, xi minus x bar whole square by n minus 1. So same as before. Now let us write all the points which we may require to solve the problem. We require xi, we require x bar, and then we require xi minus x bar whole square. So here for xi we have 1, 2, 3, 4, and then 5. And while calculating the mean for sample also, we will get the mean same as population. So we may write 3 here. Why I am directly writing 3 here? Because I have already calculated it for the population which has the same data points. So it will not differ even a single point between sample and population while calculating mean. So I have written the same things, and it is also going to be same one. So I'm writing 41014. So while we summate it, we will get 10. So based on the formula, now S square will become S square will become 10 by n minus 1. That means 10 by 5 minus 1. So that is going to be 10 by 4, which equals 2.5. So here, as you can see, that we have calculated both population variance and sample variance. In variance of population, we got variance is 2, but in sample, we got variance as 2.5. This is all about variance, and now let us discuss about standard deviation also. So as we have seen about variance and we have calculated variance for both sample and population, now we can move further to the standard deviation. So standard deviation, if you know about variance, it is going to be super easy for you to understand about standard deviation, because it is nothing but the square root of variance. So a standard deviation is nothing but square root of variance. So if variance is sigma square for population, then the standard deviation is going to be just sigma, because while doing squares we'll cancel it. So that's why while doing square root we will cancel this and this one. And for sample deviation, it is going to be s, because while doing square root of s square, which is for sample variance, it will be cut off and we will have our sample standard deviation as s simply. For example, if my variance of population is going to be 100, then the standard deviation will be going to be 10. Or else, if my variance of the sample is going to be 49, then my standard deviation of the same will be becoming 7, because 7 square is 49. So this is all about standard deviation. If you really understand about variance, standard deviation is going to be super easy for you and you can understand it very well. So this is the end of the video, and if you like the video, please do like the video, and also it would be helpful to me if you share the video with your teammates or your friends or colleagues. And also I would highly recommend you to follow my playlist, which I'm going to give the playlist link in video description, so that you can learn statistics which will be used for data science from very basics to the very strong level of skills, so that it can be really helpful to you to understand in a more easy way about the statistics. And also, if you like the content of my channel, I would highly recommend you to subscribe to my channel. So with this, I'm going to be thanking you all, and let us meet in the next video in the playlist to discuss about next topics in the statistics for data science playlist. Thank you.